This is why cruise ships never run out of fresh water, when every surrounding drop is literally poison. The first step in this survival cycle is pure thermal theft. A cruise ship doesn't waste massive amounts of electricity heating up its water. It hijacks the fever from its own engines. These massive iron blocks generate a lethal amount of heat that has to be managed by a jacket water system, basically a constant 80° centigrade river of coolant that keeps the engine from melting down. It sounds like a simple cooling loop, but the second this heat exchange stops, the ship's entire freshwater production flatlines, forcing the crew into a fuel-burning emergency. Instead of venting that thermal energy into the atmosphere, the ship routes it through a shell and tube generator to act as a free burner. By using this waste energy to hit the incoming seawater, the vessel effectively turns its propulsion system into a massive zero-cost kettle. It's a high-stakes recycling act, where the engine's potential breakdown is what keeps the passengers' taps running. But here's the problem. Even with a scorching engine, boiling seawater at sea level is a fuel-burning nightmare. To actually win this war, the ship has to stop working harder and start tricking the atmosphere into doing the work for it. Even with a massive engine pumping out heat, you face a brutal physics problem. Boiling seawater at sea level takes a staggering amount of energy. To get around this, the ship's evaporator doesn't try to work harder, it cheats the atmosphere. Inside the shell and tube generator, the ship creates a powerful vacuum that mimics the low-pressure environment of a mountain peak. By dropping the internal pressure, you can force seawater to boil and turn into vapor at just 40° centigrade, barely warmer than a summer day. It's a delicate atmospheric lie that must be maintained perfectly, because if the vacuum seal leaks for even a second, the water refuses to boil, and the entire 250-ton machine becomes a useless floating paperweight. This cool boil is the one way the ship can produce massive volume without melting its own pipes. It's a game of pressure where the ship's survival depends on maintaining a fake environment that defies the natural world. You can't just create a vacuum and walk away. The second you stop fighting for that low pressure, the physics fail, and that's where the 6-bar mechanical punch comes in. A vacuum doesn't stay put, as the ocean is constantly trying to crush it back to reality. To fight this, the ship uses the ejector pump, a high-pressure workhorse that acts as the mechanical lung of the freshwater system. This pump slams pressurized water through an inductor at a staggering 6 bar, creating the violent suction needed to rip air and brine out of the generator shell. It's a relentless 24-hour sprint that moves up to 30 cubic meters of fluid every single hour just to keep the internal pressure low enough for the water to boil. If this pump's pressure dips below 3 bar, the vacuum collapses instantly, effectively suffocating the desalination process and leaving the ship's tanks bone dry within hours. There is no resting for this component. It is the brute force that holds the physics of the entire ship together. Without this constant punch, the engine's heat becomes worthless and the freshwater cycle stops cold. This starts a violent 24-hour race to dump a toxic byproduct before it physically eats the engine from the inside out. As the seawater boils off into pure vapor, it leaves behind a lethal concentrated sludge known as brine. This salty water is a corrosive mineral-heavy byproduct that the ship must purge every single second. Think of this as the ship's kidney. It uses raw suction to blast waste back into the deep before it can calcify into solid salt rock and choke the machinery from the inside out. If this adductor fails for even 30 minutes, the boiling chamber begins to scale up with solid salt rock, choking the heating tubes and contaminating the fresh water with rust. You cannot let the salt settle. It has to be a constant, violent evacuation. If that sludge isn't cleared, the thermal efficiency of the engine heat hijack drops to 0, and the machinery effectively eats itself from the inside out. It is a relentless race to dump the waste before it can cement itself into the ship's iron heart. With the brine cleared, now the ship has to set an invisible trap for the microscopic salt particles that are currently riding the steam towards your glass. When water boils under a vacuum, it doesn't rise in a clean, perfect mist. It creates a chaotic spray that carries tiny invisible droplets of salt water upward. To stop this, the ship uses the demister, a dense multi-layered mechanical mesh that acts as a final physical wall. As the vapor rushes toward the top of the shell, it has to weave through this tight labyrinth, which catches the heavier salt droplets and knocks them back down into the brine. A tiny tear in this mesh means the fresh water being produced is instantly contaminated, turning the entire supply into a brackish liquid that people can't drink, meaning there is zero room for a microscopic gap here. If the demister fails, the ship is no longer making life-sustaining water, it's just moving the Atlantic Ocean from the outside to the inside. It's what's standing between a refreshing shower and a mouthful of brine. Now you're on a razor-thin edge where even a 2-degree warming in the pipes turns your drinking water back into useless steam. The final stage of the fake atmosphere happens at the very top of the generator shell in the condenser. After the salt-free vapor passes the demister, it hits a wall of cold seawater pipes that shock the steam back into its liquid form. This is a thermal collapse, where the vapor loses its heat and rains down as pure distilled water. It is a razor-thin balancing act because if the cooling water temperature rises, the vapor refuses to condense, leaving the ship with nothing but useless pressurized steam. You're essentially fighting a thermometer. 1 or 2 degrees of deviation in the cooling pipes turns your drinking water back into useless pressurized steam. This is the moment where the miracle actually happens, as the engine's stolen heat is finally traded away for a steady drip of life-saving hydration. You've made the water, but now you have to face the system's automated tongue, a kill switch that values purity over everything else. This is the salometer. It doesn't guess, it monitors parts per million with a mechanical coldness that values purity over volume. As the freshly condensed liquid drips into the collector, the salometer monitors the electrical conductivity of the water to ensure it's pure. This is a zero-tolerance audit, where even a microscopic trace of salt triggers an immediate mechanical lockout, slamming the tank valve shut and dumping an entire hour's worth of production back into the ocean. The ship does not negotiate with quality. If the salinity spikes by even a fraction, the solenoid bypass valve diverts the flow to the bilge instantly to prevent poisoning the main reservoir. It is a brutal, high-stakes filter that values purity over volume. If the salometer screams, the entire cycle effectively resets, leaving the ship's thirsty infrastructure waiting for a clean slate. Still no time to celebrate. The ship has to produce exactly what it consumes in real time, or the taps go bone dry. The final stage of this mechanical war is the distillate sprint. The freshwater pump is a high-speed workhorse tasked with moving over 5,000 liters of finished product every single hour into the vessel's massive storage network. It's about maintaining a constant pressurized flow that feeds every kitchen, cabin, and laundry room on a 250,000-ton machine. This creates a dangerous buffer problem, where if the passenger's consumption rate exceeds the ship's capacity, the ship's reserves hit zero, and the internal ecosystem collapses.